Okay, so today's notes are on the distributive property and greatest common factor. Our content objective is to simplify expressions using the distributive property and to rewrite expressions by factoring out the greatest common factor, or GCF. Our language objective is to correctly explain how to rewrite expressions using the distributive property. So we're going to start with a quick check, so that's what QC means, quick check, and I want you to try on your own real quick to simplify these two expressions using the distributive property. So if you want to pause to try on your own, now we're going to use the distributive property here to do this. So if you've forgotten, distributive property means you're going to multiply, when you have something in parentheses being multiplied by another number out front, you just multiply it by each term inside. So 3x times x is going to be 3x squared, because x times x is x squared, x plus x is 2x, but x times x is x squared. Then 3 times negative 7 is negative 21, and the x stays on there, so it's 3x squared minus 21x. I'm going to do the same thing here. Notice that this negative 2x does not get distributed over here because that 1 over here is not in parentheses. So then negative 2x times x is negative 2x squared. Negative 2x times 1 is going to be negative 2x, and then that minus 1 stays on the end. I can't combine any like terms, so that would be my answer for that expression as well. All right, so this is just the basics of distributive property that you hopefully have done before. I know it's come up in some of the problems we've done, so I know I've seen you guys do this, so hopefully this is a review, but I want to jump into multiplying binomials. You may remember this, hopefully you do. If not, that's okay, we're going to go over it today. So when you have a binomial, first of all, a binomial is something with two terms in it. So binomials are two terms. So bi means two, nomial is numbers, so two numbers. So each of these are binomials. So this is one binomial, this is another binomial. If we're going to multiply them, we're also going to use the distributive property, but there's a mnemonic device you can use to help you remember this called FOIL. So we're going to multiply the first terms first. So if I have x minus 5 times x plus 3, which is what I have, I'm going to multiply the first terms here. So these are my first terms. Then I'm going to do the same things with my outer terms. So O stands for outer, so these two would be my outer terms on the outside edge. So the first terms in each set of parentheses, now the outer terms in each set of parentheses. So sorry, I didn't write this down. I have x squared when I multiplied my first terms. Now I have plus 3x when I multiply my outer terms. Next I have inner terms. So that would be the ones closest together here, the inner. So negative 5 times x is negative 5x. And then my last terms. So that would be negative 5 and 3, which is negative 15. So that's how you can multiply, FOIL. So when you have binomials, you can FOIL them. The main thing is to remember that each term gets multiplied by each other term in the parentheses. So x times this, negative 5 times this. Make sure every term gets multiplied. Lastly, you need to combine like terms. So x squared, there's no other x squareds, 3x, and negative 5x becomes negative 2x minus 15. And that is my answer for that problem. We're going to do a quick check, or a couple of quick checks with that, just to make sure you guys understood what we did. So I want you to do the same thing, but this time I have x plus 2 times x plus 7. And then a second one, a little more challenging, I'm going to have negative parentheses 2x minus 1 times x plus 3. So there's a couple different ways to do that one, but try it out on your own. Pause if you need to. I'm going to go over it now. So I multiply my first terms, I get x squared. I multiply my outer terms, I get 7x. I multiply my inner terms, 2x. Last terms, 14. Combine my like terms in the middle, and I get x squared plus 9x plus 14. That's my answer for that expression. This one I can follow the same process. What I'm going to do personally is leave that negative in front for the whole time and then deal with it at the end. If you would prefer to distribute it first, you may. I'm going to suggest that you get in the habit of ignoring it for the time being because it'll prevent you from dealing with really large numbers later on. So I'm going to do my first term. So I have my negative out front first, 2x squared. Outer terms, I have 6x. Inner terms, I have negative x or negative 1x. And then I have negative 3. I'm going to combine my like terms. So then I have 2x plus 5x minus 3. And then last, I'm going to distribute this like I distributed in these problems up here. I'm going to distribute my negative 1 to each number in there. So I have negative 2, sorry, I lost my square there. Negative 2x squared minus 5x plus 3. And that is my final simplified expression for that expression there. All right, make sure you write any questions you have on that down. I'm going to flip the page because now we're going to try going in the reverse order. So in those last problems, we were multiplying numbers in. So some of them were binomials, but if you think back to our first quick check, we are multiplying those numbers in. Now we're going to do the reverse. We're going to factor. So by finding the greatest common factor. So we're factoring out a greatest common factor. So that's what this second part of our notes is going to be about. So our first example, I want us to factor 6n squared plus 9n. So we're going to factor that. So when we're trying to find a greatest common factor, this is basically reverse distributing. So instead of multiplying numbers into parentheses, we're going to divide a number out and put it in front of a set of parentheses. So the first thing I need to do is determine my common factors. So numbers that go into both 6n squared and 9n. So this means I need to check both the variables, so n's, and the coefficients, 6 and 9. So check both variables and coefficients. So here, I'm going to write this over here. My greatest common factor, I know that 3 goes into both 6 and 9, and that's the largest number that I know of that goes into both of those. So 3. I know both of these have at least one n, because if there's no exponent, the invisible exponent is 1. So I know I can take out at least one n. So my greatest common factor here is going to be 3n. So then my second step is going to be what I said before, reverse distribute or divide out. So when I say reverse distribute, that is not a technical term. It's more of a mnemonic device for remembering what you do here. Reverse distributive property or divide out. So I'm going to take 6n squared plus 9n, and I'm going to divide them both by my GCF that I found, or my greatest common factor. Excuse me. When I divide them out, I get 3n in front. So the number you divide by goes in front. 6n squared divided by 3n. 6 divided by 3 is 2. N squared divided by n leaves me with just 1n. 9 divided by 3 is 3. N divided by n cancels it out, so I'm all done there. So that is my factored form of that expression. So again, we're reverse distributing, so now we're creating parentheses rather than getting rid of them. So I'm going to do one more example because I'm guessing this might be new for some people. So our next example is going to be 12a to the 4th minus 8a squared. So again, my steps are the same. We're going to determine common factors. So one thing or two questions you can ask yourself to help figure out the greatest common factor is how many of a variable can I take out? So here I'm going to write my GCF over here again. Then most of A's that I can take out, so this one has 2, this has 4. So I can't take any more than the one with the lowest exponent. So the most I can take out is 2. So I'm going to take out a squared. And then I have to also consider my coefficient. What is the greatest number that goes into both coefficients? So that's what I'm going to ask myself. So what number goes into both 8 and 12? I know 2 does, but 4 also does, and 4 is greater than 2, so I'm going to take out a 4 from both of those. So then I'm going to divide it out. So I'm going to divide out my GCF, so I have 12a to the 4th minus 8a squared divided by 4a squared. Then I'm going to write my 4a squared in front, and I'm left with 3a squared, because 12 divided by 4 is 3, a to the 4th divided by a squared is a squared, minus 8 divided by 4 is 2, a squared by a squared cancels out, so that is my final answer. Last quick check, just to make sure we're on the same page. 16x cubed minus 8x squared. Try it on your own, make sure it's making sense. I'm going to go over it now. So my GCF, my greatest common factor, I know an 8 goes into both 16 and 8, and I know I can take out at least 2 x's, so x squared. So I'm going to divide 16x cubed minus 8x squared, both parts by 8x squared. So I divide both of those parts by 8x squared, and I'm left, I bring my 8x squared out front. So the number I divided by goes out front. I'm left with 2x. 16 divided by 8 is 2. X cubed divided by x squared is just plain x. Negative 8 divided by 8 is going to be negative 1. X squared divided by x squared is also 1. So that is my final answer. All right, make sure you write down any questions, comments, or concerns you have so we can go over them together in class.